Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Higher Tier Paper 2 from summer 2023. This paper is worth 80 marks in total, and this is the third video of 4. It will focus on questions 15 to 20, which account for 19 of these marks. AQA Paper 2s are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 15. Expand these two brackets. The first bracket is x squared subtract 9xy. The second bracket is 2x add 5y. So when we expand, we multiply everything in one bracket by everything inside the other. So let's start with this. X squared times 2x is 2x cubed. X squared times positive 5y is positive 5x squared y. Negative 9xy multiplied by 2x is negative 18x squared y. Negative 9xy multiplied by positive 5y is negative 45x y squared. So now we need to see if we have any terms that are like terms so that we can collect them together and simplify. We've only got the 1x cubed term, so that's going to stay as it is. We've got x squared y, and we've also got x squared y here. So these are like terms. This one isn't, because the x isn't squared, the y is. So these two here can be combined as they are like terms. So we are starting with positive 5 and subtracting 18. You've got a calculator, so if negative numbers fuzz your brain a little bit, pop it in your calculator. Negative 13 x squared y. And then we've still got the negative 45xy squared because there were no other terms to combine it with. Now I'm happy with this. I'm going to pop it on my answer line. Question 16. Line A has equation y equals ax subtract 1, and it passes through the point 7, 13. Line B has the equation 5y subtract 3x equals 4. Show that the line A has a greater gradient than the line B. So let's focus on line A to start off with. So the equation of a straight line is y equals mx plus c, and the m is what tells us the gradient. In this question, the m is a, so we don't know the gradient of line A to directly compare it, so we're going to have to figure out what that value is. It gives us a coordinate that it passes through. Remember, coordinates are x and y coordinates. So I'm going to substitute this x and this y value into line A's equation. So y equals ax subtract 1. Well, y equals 13. X equals 7, so that's 7a subtract 1. Now I'm going to solve this for a. So I'm going to add 1. And then I'm going to divide by that 7. So a equals 2. So line A has the equation y equals 2x subtract 1, which tells me that the gradient of line A is positive 2. Okay, now we need to find the gradient of line B. So we're given 5y subtract 3x equals 4, but it isn't really in this form. So I'm going to rearrange this equation. So I'm going to add 3x to both sides, because then this moves my 3x over to this side. So I'll just rewrite that slightly just to make it a little bit more sense. So now we've got our mx plus c. The problem here though is it's 5y, not y. So what we're going to have to do is divide by that 5. So divide by 5, y equals 3 over 5x, add 4 over 5. So the gradient of line B is 3 over 5. So 3/5 is less than 2. So line A, has a greater gradient. Question 17. So we've got a triangle formed by two right-angled triangles. Work out the size of angle X. So this is angle X. And when I'm dealing with right-angled triangles, I'm either going to use Pythagoras or trigonometry. To find the angle X, I'm going to have to use trigonometry, but to do that, I need the value of two of the sides. So I'm going to have to either find BC or AC. Now, currently, I have no information that's going to help me find BC whatsoever, but I do have this triangle here, the hypotenuse and another angle, so I could find AC. So let's start by finding AC. So we're going to ignore this triangle to start off with. So the 4 is the hypotenuse. This must be the opposite because it's opposite the angle, which tells us that AC is the adjacent. So if I'm finding the adjacent, this is the one I'm finding, this is the one that I know. So adjacent and a hypotenuse, I'm going to be using this trigonometric ratio. The C stands for cos. So cos 37, because that's the angle we're given, equals the adjacent divided by the hypotenuse. So let's substitute in what we know. The adjacent is what we're looking for, it's AC. And the hypotenuse is 4. Now, because I'm looking for the adjacent, if I cover that up in my triangle, I'm doing cos multiplied by the hypotenuse. So AC is equal to cos 37 multiplied by that 4, which is 3.19454,204. So now I know what AC is. I'm going to ignore this smaller triangle, work with this bigger triangle, and I'm going to then attempt to find the angle X. So let's start labelling the sides now on this bigger triangle here. So we're ignoring that smaller one, we're just working with this triangle now. If it makes life easier for you, grab yourself a sheet of paper, cover that information up so you don't get confused, okay? You can ask for scrap paper in your exams, that's not a problem. You just can't submit it as part of your exam paper. So let's relabel this triangle. Opposite the right angle is the hypotenuse. Opposite the other angle, whether we know what it is or not, is the opposite, which means this side BC must be the adjacent. So we want to find the angle. So we know what the hypotenuse is, and we've just worked out AC, so we know what the opposite side is. So we're now dealing with this ratio triangle. S stands for sin. So sin X equals the opposite over the hypotenuse. The opposite we've worked out up here. So sin X equals 3.19454,204. And the hypotenuse we know is 9.3. The issue is here we're finding X. So we're going to have to do the inverse sin of all of this. So 3.19454,204 over 9.3. So that's what we're going to stick in our calculator. So to find the inverse sin function, you press shift and the sin button. Same for if you were working with cos or tan. So let's put a fraction in there, 3.19454,204, 9.3, arrow away from the fraction, close your brackets and press equals. So we have 20.09020484 degrees for that angle. Now if we go back to this question at the top here, guys, it doesn't say what to round the angle to. Usually we work to 1 decimal place for angles, so let's do that here. I've written the full thing just to be safe, but to 1 decimal place that's 20.1. So I'm going to write 20.1 to 1 decimal place on my answer line. Question 18. Rearrange y equals x add 8 divided by x to make x the subject. So the first thing I'm going to do is I'm going to get rid of this fraction. So I'm going to multiply both sides by x. So the left-hand side becomes yx, and then the right-hand side becomes x add 8. I've eliminated that fraction. Now what we notice is we've got the letter x that we want to make the subject in this equation twice. So I want to make sure that all terms with an x in are on the same side of the equation. So let's move them so that they're all on the left-hand side of the equation. So instead of having positive x here, I'm going to subtract x from this side, which leaves 8. And then when I subtract x from this side, I have yx subtract x. Now I'm going to factorise the left-hand side because I only want one version of the x. So if I pull out a common factor of x, y times x becomes y, and the negative x becomes negative 1. Now that I've factorised and got the x in 1, I'm going to divide by that bracket. So x equals 8 over y subtract 1. It's important when you're dividing that the whole thing goes underneath and we write it as a fraction. And then I'm going to pop that on my answer line. So x equals 8 over y subtract 1. Question 19. Here are the first 4 terms of a quadratic sequence. So knowing that it's a quadratic sequence is important. 3, 20, 47 and 84. Work out an expression for the nth term of the sequence. So, first of all, let's find the difference between the terms. So to get from 3 to 20, we add 17. 20 to 47, we add 27. And then that's gone up by 10. And now it's a quadratic sequence. I'm expecting them to go up, the differences to have the same difference between them, if that makes sense. So 84 subtract 47, I'm expecting 37. Yeah, that's right. So add 37. So that's our first difference. So then we work out the second difference, the difference of the differences. So from 17 to 27, add 10. 27 to 37, add 10. So that second difference here is important. Half of that gives us our A term. So A is 10 divided by 2, which is 5. So that tells us we have 5n squareds in our nth term for this quadratic sequence. So now what we're going to do is we're going to generate the sequence for 5n squared. Now, let's use n values. So we've got first term, second term, third term, fourth term. So first, second, third, fourth. Remember, you've got a calculator that you can use at all points throughout this. So 5n squared, if n is 1, 1 squared is 1, times by 5 is 5. If n is 2, 2 squared is 4, times by 5 is 20. If n is 3, 3 squared is 9, times by 5 is 45. And then 4 squared is 16, times by 5 is 80. So what I'm going to do is I'm going to write this sequence underneath here now. So we've got 3, 20, 47 and 84. And I'm going to compare what happens to get from here to here. So from 5 to 3, subtract 2. 20 to 20, nothing. 45 to 47, we've added 2, and then 80 to 84, we've added 4. So now what we're going to do is we're going to find the linear nth term for the differences between 5n squared and the sequence that we're trying to find the nth term rule for. So from negative 2 to 0, we add 2. From 0 to 2, we add 2. And then from 2 to 4, we add 2. So it's 2n, and then to get from 2 to minus 2, we would subtract 4. So we have 5n squared plus 2n subtract 4. So both parts of this go together. Let's just double check though before we stick that on our answer line. So For the first term, it's 3. So when n equals 1, that first term, 5 is 1 squared. So that's what we're going to work out here. And what we're expecting is an answer of 3 if our nth term is correct. So 1 squared is 1 times by 5 is 5. 2 times 1, subtract 4. Okay, 5 plus 2 is 7. 7 subtract 4 is 3, which matches the first term in our sequence. So we can confidently write this nth term rule on our answer line. 20A. P, Q and R are points on a circle. S is a point inside triangle PQR. So P, Q and R are points on a circle. S is that point there inside this triangle. Assume that S is the centre of the circle. Work out the size of the angle X. So this is circle theorems. If S is the centre of the circle, then the angle at the circumference X should be half of this angle at the centre. So 130 divided by 2 is 65 degrees. So we can, assuming that S is the centre, say that X is 65 degrees. 20B. In fact, the centre of the circle is on PS. So somewhere here, but not at S. What does this mean about the size of angle X? So is it the same? Is it greater than, smaller than, or is it impossible to tell? Well, it's impossible to tell because we don't know where it's going to be on this line PS. It could be anywhere, couldn't it? So it's impossible to tell at this stage. 20C. For a different circle, AB is a tangent at A. C and D are on the circumference of the circle, and AC is equal to CD. Here is Simon's method to work out the size of angle Y. He says that angle ADC equals 70 degrees for the alternate segment theorem. Therefore, Y equals 70 degrees because of angles in an isosceles triangle. Is he correct? And give a reason for your answer. Okay, so he's used the alternate segment theorem here. He's not correct because it's not the angle ADC that would be 70. It's the angle ECD here that would be 70 by that rule. So, no, he's not correct. It's ACD that equals 70 degrees, not ADC.